Hello students, good evening everyone. Welcome or welcome back again to another video tutorial lesson from the AP3X Institute of Mathematics Education. My name is Akin, your math instructor, and in today's video we are once again reviewing a most recent examination, or I would say tri-weekly, bi-monthly exam to which I had administered to a particular group of students, primarily in the evening division. And of course most of you guys would have already gotten back your results, or you are going to be getting your results in short order. So by watching this tutorial, the primary focus and aim is to highlight where you may have went wrong and to give you the corrections that you may need going forward as a group of students being prepared for the 2023-2024 Math CXC exam. Now, I did find that as a group you all did a lot better than what you did in the previous tutorial. Definitely guys, you can go ahead and check out that tutorial video. I'll be leaving a link in the description box below for you to that previous tutorial, or you can just check on the channel playlist. You will be able to see that previous exam. Now we are, I guess safe to say, 2 months into the school term, and we have covered quite a bit. We are currently in the ending phase of the topic of measurement, and we are entering to the middle phase of algebra. We have already covered fundamental mathematics, and of course we're going to be continuing to do these types of questions because they are primarily what attracts the most marks as a whole on the exam. Of course, if this is the first time here on the channel, do not forget to hit the subscribe button below guys. Turn on your post notification bell to be notified on a weekly basis when I post tutorial videos, and of course leave some positive questions and comments down below. Let me know your thoughts, if the video was of any aid, any help to you, if it was beneficial to you, and if so, do not forget to hit the share icon. It really does help the channel to grow by also hitting the like button. Alright, so we're gonna take our time. I'm hoping that maybe we can get this done under an hour, but we may go a little bit over an hour because I want to really dive into the different aspects of the thought process. Now, a lot more students did better on this exam, which is good, because as the exam gets a bit more challenging, as the paper, the structure of the question becomes more exam structured like, then you guys performances should be declining a little bit, or being maintained on the same level. But as a group, as I said before, you guys did a lot better, and I'm seeing a lot more potential in all of you. So congrats to those who did well on the exam. I believe the highest mark on this exam was 96%. Some advanced students may be seeing this video for the first time. It's not a challenging topic, but trust and believe that we have many students who have made brutal errors on this paper. So it is just in preparation for this, and this is just a video review tutorial primarily for those particular students. Alright, so let's get into it. Now, there are a few corrections that I need to make before getting into the video. This value, I will have to change it in the end. I did let my students know that this value needs to be changed, and there are some groups of students that were allowed to do question 5, and there were some students that were allowed to do question 6 because I'm at different stages of the curriculum with those students. But let's get right into it here. Any corrections that need to be made will be made accordingly. Alright, so let's jump right into the lesson. What a lengthy introduction that was, but here we go. First question, but let's read the instruction. Of course, I work at the Institute of Manchester Learning, Manchester Institute of Learning, and the instructions, of course, as always, will be to answer all questions and show your working where necessary. Alright, so here we go. First question that comes on the paper is in fact a fraction question, which is traditional for CSEC examinations, and what we have here is in fact 5 and 3 over 5 divided by 1 and 5 over 9 subtract 1 1/5 squared, all divided by 2 3/4, valued at 4 marks. So if I go across the page here and then we look, the very first thing that you guys should be doing, and I find that quite a few students got this question correct, but still I have that student who is reinventing the math and not applying the concepts, getting a few things mixed up, adding, finding LCM when you're not, mixing up the rules of PEMDAS. But here we go. So very first thing here is in fact that we are going to be converting all our mixed fractions to improper. So what we have here is 5 times 5 is 25. 25 plus 3 is in fact 28 over 5, divided by 9 ones 9, and 5 or plus 5 is 14 over 9, subtract 5 ones 5, plus 1 is 6 over 5 squared. Okay, now let us just focus on this top part of the problem first. Just evaluate that to one answer. Now we know that when we're dividing fractions, it's really the opposite of multiplication. So we're going to write our 28 over 5, and we're going to be changing this sign to a multiplication and inverting the last fraction. So that is in fact going to be 9 over 14. So that's 9 over 14, and we're going to be taking away. Squaring means that we're going to be multiplying the numerator and the denominator by itself. Now you find that some students will do this, 6 over, you find that some students will say 6 over 5 multiplied by 6 over 5. All right, you can do that, or you can simply say 6 squared is 36 and 5 squared is 25. Now we have two different operations which in fact have two different rules. So for multiplication, we are clearly looking for something to cancel. So if we can perhaps say here 14 into itself one time and 14 into 28 two times, then we're gonna find that the left side of this problem here reduces to 2 times 9 is in fact 18 over 5 times 1 is 5. Then we're going to be subtracting the result of 36 over 25. So therefore then we're going to go ahead here and find the LCM, because we are in fact subtracting two fractions. Now I find that a couple students, as I said, most students got this correct, but a few students made an error by using 5 as the LCM. Remember that LCM means the lowest common multiple that both numbers can go into at the same time. So the LCM here is 25 for that student who made that error. Then clearly you can see why you would have lost maximum marks on this question here. So 5 into 25 goes in fact 5 times, and 25 into 25 goes 1 times. So therefore 5 times 18 is in fact 90, and 1 times 36 is in fact 36. So if we take this away here, we'll end up with 54 over 25. That is the result of the A section of this problem. We can therefore then transfer this information up here, and then we know that that 54 over 25 is going to be dividing the result, or the conversion of the bottom. So the conversion of the bottom here is a mixed fraction. So that is in fact 4 times 2 is 8. 8 plus 3 is in fact 11 over 4. Okay, and so with 11 over 4 then we end up with 54 over 25. Repeating the process that we had over here, we're going to be changing this to a multiplication and inverting the last fraction. So that becomes 4 over 11. Now it doesn't seem as if anything here can be cancelled. So if nothing can be cancelled, then we are finally left here with say here 54 times 4, and that will in fact give us 216, and then 25 times 11, that's going to be 275. Okay, and then therefore that will be our final simplified answer. Okay, so it's not an improper fraction, so therefore it's going to be left here as is 216 over 25. All right, so hopefully guys, you're not going to be making any more mistakes in the future when it comes to fraction. These are valued at, in fact this was valued at a total of 4 marks, so I felt like that was an easy 4 marks for most of you guys. All right, let's move on to the next question. Now this is a very easy question, and I find that quite a few students in fact got it right because they were allowed to use the calculator, but still I find that some students honestly found this quite a bit of challenge. You know, some persons incomplete, some persons got confused, some persons didn't know what sign to put here. So let's get into it here. All right, now of course this is a numerical problem, so we can simply use the law of PEMDAS, and that simply tells us here that we should work out what is in the bracket first. But before we actually work out what is in the bracket, what does bracket implies? Well, going forward, please be reminded that bracket implies multiplication. So I had some students subtracting, I had some students adding. Going forward, ladies and gentlemen, please be reminded that bracket implies multiplication. So the 0.54 will multiply the result of what is on the inside here, and what is on the inside here is in fact 2.15. Then we're going to proceed now to go on our calculator again, and we're going to be multiplying 3 multiplied by 1.05, which is 3.15. Now my students got a rounded off answer of 1.16 divided by 3.15, and when you guys worked it out, you got all an answer of 0.368. That was the answer that most of you guys got. Confirm with me in the comment section if that was so. Alright, so that would be the result of that evaluation, but it did went ahead here, and let's just go back to our page 1 here. It did ask us to correct your answers to 1 decimal place, 2 significant figures, and you're to also write the number in standard form. Only 1 student actually got all 3 right. Some students got A right, some students got A and B right. I think only 1 student got really close to getting all 3, and this is just a previous fundamental lesson that I would have taught a while back, maybe a month ago. But I find that if students are not kept up to par with this kind of thing, which is why on most of my exams I always bring back these types of questions, because it's something that students often overlook, and they lose valuable 3 marks like this that could add up to actually get you to over that pass mark. So nevertheless, here what we have then is in fact 0.368. So to 1 decimal place, then what we're looking at is in fact drawing a line in between the first decimal place and the second decimal place, which is in fact going to be here. Now if we check the digit that comes after here, you recognize that this digit here is greater than 5, so it increases the digit before by 1. So to 1 decimal place here we have 0.4. okay, nice. Then we're going to be moving on to 2 significant figures. All right, now of course 2 significant figures here, let's just erase here. The second significant figure in this case is in fact going to be the 6, so we're going to be drawing our line here instead, checking the digit that comes after, that is also greater than 5. So we add a 1 to the 6 and increase this to 7, so therefore to 2 significant figures we end up with 0.37. okay, and of course the question that practically every student did not get correct is converting this to standard form. Now please be reminded that standard form is the only form of approximation to which you are allowed to move your point. Now the problem that I find students having is that they either don't know which direction to move the point, or they don't know how much places to move. So as a reminder, you can definitely check out the tutorial on standard form that is on my old channel, Or you can make a request down below. I'll make a video for you if this is a problem for all of you. Here you're going to move the point right between the 3 and the 6. Why did we do that? Because the 3 is the first non-zero digit. So by moving our point, our new number then becomes 3.68. Now standard form is times 10. Now we have to have a power, and that power is depending on how much places you move and in what direction. Now if you move one place to your right, the power becomes 1, but because you move to your right and it's the opposite of the number line, then it becomes -1. Alright, and that is going to be your answer in standard form. Alright, so it wasn't a challenging question. A couple of you students made a little error with that, which is why, as I said, a lot of the marks that you guys would have gotten, you can see safely that it's just minor errors that you guys are making that's costing you marks. So easily those 30%, those 40% could have easily been converted to 50s and 60s if you had just take a little bit more time in going through these very basic concepts. Alright, let's move right along to the next question then. Now traditionally I have to keep bringing these questions back. They are in fact fundamentals, and I would go to the length and breadth to say that these questions are in fact grade 7 questions, but they matter. They actually are questions that students, believe it or not, are getting incorrect. The students are having issues with following the rules of PEMDAS. So I'm going to keep bringing these questions back until I find confidently that all, not some, not majority, but all of my students begin to get these questions correct. Now, PEMDAS. Remember guys, if you're going to be doing a problem like this, what you want to do is to give yourself a chance to get the question right. Don't try to do what you feel like doing or what you think is right. I strongly recommend that if you are a fundamental student and you know you are struggling, write down the letters that make up the mnemonic, and then what you do then is simply do a check off. Are there any parentheses in the problem? Okay, there is. So you're going to work out the parenthesis part of the problem and you're going to rewrite what is left. So we didn't have to do anything to the 15 here. Subtract. I'm going to be working out what is inside here. Now, even though we're working out what is inside the bracket, it really does matter what we do first. Now inside the bracket then we have, say here, exponent, multiplication, addition. So we know according to PEMDAS here, let's use a different color ink. According to PEMDAS, even though we're in the bracket, we know that exponent comes first, then multiplication comes next, then addition comes last. The blue, it represents what is being done inside the bracket here. So 2 cubes is going to be, say here, 8 times 7 plus 10. Then of course multiplication comes next. 8 times 7 is in fact 56 plus 10, and then of course 56 plus 10 is in fact going to be 66. So that answer is for what is inside the bracket. Then we proceed to rewrite our divide by 22. Now of course let's go back here then to our main PEMDAS that we're looking at here, and then we know that there is no more E in the problem here. There's no more E in the problem. So therefore then we end up with, say here, M. Is there any M in the problem? No, there is no more M in the problem. So of course then after M comes D. There is a D here. I find that quite a few students subtracted before they divide, and you will recognize, because you are looking at your paper at the moment, and if you're that student that got that question incorrect, you are clearly seeing that you're breaking the law of PEMDAS. So then this just simply requires here for us to rewrite the 15 and divide the 66 by 22. Quite a few students made the mistake of subtracting 22 from 66, lacking in concentration of course, but like I said, this particular tutorial here is to really get you fine-tuned when it comes to these exams. 15 take away 3, And then finally our answer here is 12. So you can see it wasn't a very difficult question. It's not a case where I made it look easy. It is in fact quite simple if you follow the law of PEMDAS. Right? Now we do have a similar question here on the other side, looking a little bit more scary, so to speak, but once you follow the law of PEMDAS, you are going to be safe. And once again, I'm not going to change. I'm going to keep it fundamental, and I'm going to go ahead here, and I'm going to go ahead and I'm going to write down P E M D A S. And for the students who are trying to interpret what is PEMDAS, some students are accustomed to GEMDAS, BIDMAS, BIMDAS, BOMDAS, BODMAS. They are all the same. It just depends on your personal preference. I personally like using the acronym Please Excuse My Dear Aunt Sally. This is what I use. Okay, so I'm gonna do a check off. Once you use this technique, you're gonna find that most of the time you're gonna get your question right. So let's check off. Is there a parenthesis in the problem? There is. So once you recognize that there is a parenthesis in the problem, you're going to rewrite everything that is not parentheses related. Okay, and then you're going to be focusing only on the parentheses part of the problem. So therefore we have 2 cubes times 3 plus 1, and this is very similar to what we just did earlier. We have to do the exponent here, so we're going to be doing the exponent here, then we're going to be doing the multiplication next, then we're going to be doing the addition last. Lots of students added before they multiplied, some multiplied before they did the exponent. Keep it simple, guys. Just follow the rules and you're going to be okay. 2 to the power of 3 is in fact 8 times 3 plus 1. Then of course 8 times 3 is 24 plus 1, which we therefore know that it's 25. So therefore the result of what is in the parentheses here is 25. Now once we have successful in that, then what comes next then is checking to see if there's any more exponents in the problem. Are there any more exponents in the problem in the second line? There is not, so we check that off there. Next then we look to see if there is any multiplication. So check multiplication. There is in fact one multiplication here. So therefore then we have 24. Take away 15 plus 1 times 50, so that's 24. Take away 15 plus 1 times 50 is 50 divided by 25. So therefore then, since we have then subtraction, addition and division, what we're going to be doing next is in fact division. Right? So we have this division aspect of the problem here. So we're going to rewrite everything that is not related to division. So that's 50 divided by 25 is in fact positive 2. Now I find that I had to give my students some of the marks. I couldn't completely give them the question wrong. I do award marks up to the point where students made a mistake. Now for my students to get to this point and I just give them the whole entire question incorrect, that's a little brutal. So I find that a lot of students didn't remember the rule about tied for priority or tied for preference. And when addition and subtraction is in the same question, then you must do whichever one comes first. If you want a complete guide on this, please check the link in my description or on the playlist on my channel. You'll find a complete tutorial that discusses this principle of PEMDAS here. So 24 take away 15 plus 2. I find that a lot of students actually said 15 plus 2 is 17, and that's where they went wrong. You are trying to force the problem by forcing addition before subtraction. Now if you decide to actually add before you subtract, bear in mind that the sign that is in front of the number belongs to the number, So if you're going to force to add, you have to remember it is negative 15 plus 2, and that's going to give you negative 13. Otherwise, if you know you're going to forget that the sign belongs to the number, just remember that whatever is tied for priority or tied for preference, do that part first. So 24 take away 15 is in fact going to be 9, and 9 plus 2 is in fact 11. So you guys would have gotten 2.5 marks, 1.5 mark, depending on where you made the mistake, but your answer is in fact 11. All right, so I'm really hoping that going forward after this elusive explanation of PEMDAS, along with my other tutorial videos, you guys should be able not to make these really fundamental mistakes going forward. All right, so that takes care of that problem. That particular question was worth, in fact, total of 5 marks. So this was 2 for this question here and 3 for this one here. Right, so that takes care of the fundamental aspect of this particular paper. We're going to be moving into the measurement section of this paper, and here's what we have then. We end up having here that the diagram below is in the shape of a swimming pool with 2 semicircles on both ends of the rectangle with a length of 9.3 and a given area of 54 squared meters. Your task is to find the complete area and perimeter of the swimming pool. I awarded a total of 6 marks for this question. I awarded 2 marks for separate sections of the question. Now, I find that my students and I have a lot of debate about which particular aspect of math is hard or easy, and I find genuinely that the English of math seems to be a challenge for a lot of my students. And why I find is that my students have a issue. If you check out the YouTube shorts on my channel, you'll find that lots of the times you'll see me doing live sessions with my students explaining how to reverse the formula. But then again, I find that also students seem to not really be able to wrap their minds around. So let's see what happens here. Now, the very first thing that I really encourage students to do is to find the clue in the question. Find the clue. And the clue in starting this question is the mere fact that they mention that the rectangle has an area of 54 squared meters. Now, the mere fact that they mention rectangle and they mention area, that kind of tells me that, hey, I will need to perhaps write down the area of the rectangle formula. So then I would start off by saying A here is equal to length multiplied by width. That's the first thing you need to do. You can't really do anything else, because the first thing that was mentioned is that the rectangle has a length of 9.3 and an area of 9.3. Has an area of 54 square meters, pardon me, and a length of 9.3. So therefore then I know that already that A is in fact 54, and they stated in the question that the length, if we can go back and look carefully where the question did in fact say that the length, it says here the length is 9.3. So the mere fact that they said that the length is 9.3, then already I know that L is 9.3. Nothing was mentioned about the width. So what does that mean for us? It means then whatever else it is that you're going to be asking us to find, we most likely are going to require to find the width. Now, even though the question didn't say to find the width, by writing down the formula, you know that the width the width needs to be attained. So let's go ahead and do that. Now, too often we've said this before, and I've not yet reached the aspect of algebra, which is solving equations, where you guys will be reminded that every single time that a number is attached to a variable by multiplication, then you simply divide both sides of the equation by what you want to get rid of. So I want to get rid of the 9.3 from beside the W, so I'm going to divide by what I want to get rid of, or you divide simply by the coefficient. then you guys would have gotten that 5.8 here is the width. Now, what students fail to do is that they fail to transfer the information on the diagram, and this is something that is more mental than it is physical. And remember that my channel primarily focus on building the fundamentals of weak students, not super smart students that would obviously know that the 5.8 here is acting as the diameter of the semicircle. Some students are not going to be able to see it that way. So what you guys need to realize here is that this 5.8 here is the actual length from here to here. That's the 5.8. So the 5.8 here is acting as the diameter of the semicircle. Now that we have found the width by using the clue in the question, what next are we going to be looking at? Now, it did say that find the complete area and perimeter of the swimming pool. So we know that the complete area of this swimming pool would have obviously been the area of this plus the area of this plus the area of this. Now, knowledge is important. Understanding math is important. Understanding roots, understanding the basic fundamental principle. If I were to say, perhaps take a semicircle here and attach it to another semicircle here, what you've just completed is a full circle. So these two ends coming together literally forms a circle. Two semicircle gives you a full circle. So therefore then, in hindsight, what we're looking at then, in order for us to find the area of the whole entire shape is going, or the swimming pool is going to be the area of rectangle plus area of the two semicircle, which basically becomes a circle. So the area of the circle, the area of the rectangle was already given to be 54. So we already know that the area of the circle, the rectangle, pardon me, is 54. Plus, we just established that two semicircle gives us a circle. So that would be equal to pi r squared. Now, I did find quite a bit of my students, because I had exposed them to two variances with the circumference of a circle. I find that a couple of my students lost extra marks because they confused pi r squared with pi d. Pi d is the variance formula for the circumference. It is not related to the area. So if you're that student who is watching this video and you made that error, then clearly you know why you would have lost the marks. So then let's go here. You weren't told exactly what to use pi as, so I did inform my students that in the event that you're not told what to use pi as, then go ahead and use 3.14, or you can attach the 2, as I have always encouraged you guys to do. R squared. Now, a lot of students completely didn't realize that, hey, the 5.8 is in fact the diameter. And so the relationship between the diameter and the radius is that the radius is equal to the diameter divided by 2. So the radius then is equal to the 5.8 divided by 2. Lots of students fell down in that department. So 2.9 squared. Let's jump onto our calculator. So then to wrap this part of the question up, we end up with 54 plus, I'm going to be opening my bracket here. Right, I'm typing everything in at once. So 3.142 multiplied by 2.9 raised to the power of 2. I'm going to close my bracket here. Whoops, pardon me. Okay, close my bracket here, and then I'm going to press equal. I end up here with an area of 80.42. So that's 80.42 squared meters. That is the area of the entire swimming pool. Okay, so it's the area of the rectangle plus the area of the two semicircle, which is a circle, which therefore then works out to be 80.42. Right, so As you can see there, guys, it's not even that I made the question look easy. It's all about understanding what the question is saying, and that's what I'm building my students up for, because a lot of these questions, when they come on the CXE exam, these are the type of mistakes that you guys make, which is what separates a grade 1 student from a grade 2 student, from a grade 3 student, from a student who fails the exam just by about 15 marks and to attain a grade 4. These are the simple things that you guys make the mistake with. Now the question did went on ahead here to find the perimeter of the shape, and so the perimeter is therefore going to be all around here. Okay, so it's going to be this section here, this curved section here, all of this section here, and this curved section around here. But just as how the two semicircle makes up the circle, so we could find the area of the circle, the two semicircle also makes up the complete circumference of the circle. So therefore then, once again, we can write a structured formula here, and we can say that, all right, the perimeter of the swimming pool is the area, pardon me, not area, it is the perimeter of, okay, let's not say the perimeter of the rectangle, because we're not going all the way around the rectangle. It's going to be these two sides, so this is 9.3 here, pardon me guys, okay, so it's going to be, say here, so it's going to be this side here, which is equal to that side, because the opposite sides of a rectangle are equal. So that's 9.3 up top, 9.3 down at the bottom, and then these two curves here make up the complete circumference of that circle. So it's going to be 9.3, let's just zoom up here guys, 9.3 plus 9.3, or 9.3 times 2, plus 2 pi r, or for some students they may use pi d. Alright, I've always been using 2 pi r, so I'm not going to veer away from that. 9.3 plus 9.3, that sounds like 18.6 plus 2 times 3.14 multiplied by, we have already calculated the radius up here to be 5.8 divided by 2, which is in fact 2.9. So that's 2.9. all right, for the person who may be using pi d, then it's going to be 3.142 or 3.14 times 5.8 if you're using pi d. So if we go on our calculator here and we were to take our time and type in our values, 18.6 plus, open my bracket, separate, 2 multiplied by 3.142 multiplied by 2.9, close my bracket here, I'll end up with a perimeter here of 36.82. all right, that is it. That is the perimeter of the entire swimming pool. So fantastic. As I'm remembering here, I might have given my students some extra marks because I don't remember seeing any of my students writing down this value, so they may have made a mistake and I didn't realize. But that is it. All right, that is it. Double checking and making sure that everything is good. Right, I think we have it. 2 pi r, yes we do, we have it, everything is okay. All right, so that is what was required, guys. It wasn't a tough question. These questions are questions that you guys do in my class, so you've got to get rid of those little nerves, guys, and remember that a math exam is just like a regular class exam. You just got to have the mental state of mind and be ready and be prepared. Okay, moving right along then, we are about 40 minutes into this particular tutorial. Let's move on to the next question here, which is in fact to determine the area of a triangle with side lengths 11.5, 5.7 and 15.3. and so this requires a very simple formula. Okay, and this was disclosed to my students that if you are required to find the area of a triangle when all three sides are given, then you have to use the Heron's formula. And funny enough, the formula was actually written on the board. So a lot of the times I find that students don't necessarily have a problem using the formula. What they have a problem with is in fact knowing when and which formula to use, because we all know that with the triangle has 3 different formulas for finding the area. And of course, we already know from previous tutorials on this channel that we discussed that the area of a triangle is not determined by the type of triangle, but it's determined by the information provided to you about the triangle. So we were provided with 3 sides, which brings out the formula square root of s bracket s minus a, s minus b, s minus c, where s then is equal to a plus b plus c divided by 2. And s, for everyone's information, s stands for the semi-perimeter. So for the semi-perimeter then, what we're looking at is half of the perimeter of this particular triangle. So then s then would have been equal to, as you said here earlier, 11 point. Let me go back and make certain that we have the numbers correctly. It is 11.5, 15.3, and 5.7. 11.5. Okay, so that's 11.5 plus 15.3 plus 5.7, and that is in fact going to be divided by 2. So the semi-perimeter, if I remember correctly, and I'm going to double check, right? I'm going to double check here. So I have 11.5 plus 15.3 plus 5.7, and I'm going to divide the answer here by 2. In fact, all my students, most of my students got the 1 mark for this question. I gave you all 1 mark just to attain the S value. Now to wrap this question up, obviously we know that the formula, the main formula, contains repetitive semi-perimeter. So we know that S is a requirement then. So we have the square root then of 16.25. Few students, not few, I think 1 particular student rounded off to 16.3. I don't recommend you rounding off before the problem is completed, because you're going to get an inaccurate answer that may fall outside of the margin of error. So I recommend that whatever this number you have here, use it as it is. Alright, not that it's going to be incorrect, but let's play safe. Use whatever is calculated. So 16.5, open bracket, you'll see S repeating itself, 16.5. Take away, we chose the value A to be 11.5. Once again, S repeats itself, 16.5, 16.25, pardon me. You can see I made an error here. It should have actually been 16.25, pardon me. Take away B value, we chose to be 15.3. And therefore then, I think I might be running out of space. Let's just do that again. Might be running out of space here, guys. So let's do it a little bit smaller. So that's 16.25, open bracket 16.25, take away 11.5, 16.25, take away 15.3, and 16.25, take away 5.7. Alright, so then let's rewrite our square root, and we're going to be working out what is inside the brackets, because of course we are working with PEMDAS. This is something that I've explained to my students that follows you everywhere you go. 16.25 take away 11.5, that gives you an answer of in fact 16.25 multiplied. We already stated that multiplication bracket implies multiplication, so 16.25 multiplied by the result of what is in this bracket, which is 4.75. Multiplied then again by 16.25, take away 15.3, we end up with 0.95. Multiplied then by 16.25, take away 5.7. and that's 10.55. all right, simply now some students left it right here. Maybe a little bit of nerves got the best of them, but let's wrap it up, guys. 16.25 multiplied by 4.75 multiplied by 0.95 multiplied by 10.55, and we get an answer here of the square root of 773.61. By going ahead and finding the square root of this result, 773.61, we attain a final result here for the area to be 27.81. all right, perfect result that we have here. Okay, and that's going to be meters squared. Is it meters? Let's double check what the unit of measurement is. It is in fact, say here, centimeters. So it is in fact centimeters squared here. Okay, all right, guys, so we're going to be moving on to the next question, and we're going to be looking in fact at the variation aspect of the paper. And one of the issues that I find, or one of the issues that I realize that my students have, is not just recognizing the different types of variation questions, but they oftentimes overlook, and I'm looking at majority of my students overlooking the relationship between the variables. Now, if we take for example here the fact that question 3 speaks of the speed of an object varying inversely as the cube of its distance, what I find is that a lot of students tend to overlook this aspect of the problem. And so different relationships are created between the variables, where sometimes it is the cube of the distance, it could be the cube root of the distance, it could be the square of the distance, the square root of the distance, it could be anything. So a lot of you guys who may have gotten this question incorrect only got it incorrect simply because you wrote down the incorrect formula. Your principles were right, everything that you did was okay, but you wrote down the incorrect relationship between the variables. Now, in this question here, we're looking at the fact that the speed s varies inversely to the cube of its distance. So we're no longer looking at the traditional method or the traditional formula y varies as x, but in this case here we're changing the variables that we're using. So now we're looking at s varying directly as d, but bear in mind that d has to be cubed. So then what we're looking at then is setting up firstly here the traditional formula of, say here, y equals k divided by x cube. Okay, so once we have set this up here, okay, just a second guys, once we have set this up here as y equal, say here, k divided by x, notice that x is now representing the distance, which is now d, but they did say in the question that it is the cube of its distance. So we have this formula that I have placed in a brown box here that represents, say here, the formula that we're going to be using throughout this question here. Now, very importantly, you recognize here that with this blue arrow here, this is showing you that an important value needs to be attained. And in this value here, what we're looking at is finding, say here, k. So of course we're going to go over here and we're going to in fact say here, write down s is equal to k divided by d cube. Now in the question it did say that the speed of the object is 80 kilometers per hour and the distance traveled is in fact 2 cubes. And how did we know this? Because it did refer, or it made a reference to the table that we have up here. Now quite a few of the students expressed that they have a distaste for variation whenever it's on a table. But the same procedure as when the question is worded, ladies and gentlemen, is the same procedure that you apply when the question is in a table. Now in the table, it is more of a direct line towards the number, where you are clearly seeing the number. You're clearly seeing the numbers that are in the rows. So here for this table here, you recognize that 80 and 2 are the first initial values. Now for some questions, you may find that the two initial values are sometimes in the first column, or like in this example in the second column, or like in this example in the third column. But say here 80 and 2, S is 80. 80 is in the row of where S is, and 2 is in the row where D is. So these are the two values that we're going to be using to establish the value of, say here, K. So that is how we have S is 80 and D is in fact 2 cubes. Now 2 cubes is 2 multiplied by 2 multiplied by 2, which is in fact, say here, 8. And of course, when the unknown variable, doesn't matter what it is, if the unknown variable is in the numerator of the equation or the numerator of the fraction, then we're going to cross multiply. So we're going to cross multiply here with here. So 80 multiplied by 80 gives us the value of K. Therefore, K is 640. And of course, as always, we know that K is the starting value that we need. Now, as I've always encouraged all my students, that always rewrite your formula. Always rewrite your formula. So once again, I've written down here, S is equal to K divided by D cube. Now we're going to go back to the table and look at which aspect of the table we need to fill out. Now in this aspect of the table, you'll recognize here that we were given 15.5, but the row where S is empty. That means that value is unknown. So S is unknown. So going back to our calculation here, you'll recognize easily that S is the unknown variable, and K, which we just calculated to be 640, will be divided by the distance, which is 15.5, but do not forget to cube it. Now S equals 640. When we multiply 15.5 by itself 3 times, then we'll get an answer of 3,581.58. This is a rounded answer. Then of course, dividing both numbers on your calculator, then that will give you a rounded answer of approximately 0.176, I think, which basically would be rounded off to 0.18. Now I'm using 0.17 because I have already rounded here. Okay, it's within the margin of error, so 0.18, 0.17 are both acceptable for this particular problem. All right, so that's what was required to solve that particular problem. Let's go back to the table then and look at the final column here. So the final column here is in fact that S is then now 125 and D is in fact, say here, unknown. D is unknown. So we're going to go back and write our formula. And you'd have seen here that I've already done most of the calculations. I'm just walking you through what I've done here. So our formula here once again is S is equal to K divided by D cube. So S is in fact 125, and we've already calculated K, which is all the way over here, 640, and D in this case is missing. Okay, D is missing. So now we're doing the opposite of what we did in example number 1 here, or the part where we found K. Now we're looking at the unknown variable being in the denominator of the fraction in the equation. Okay, so therefore then once your variable is in the denominator, we're going to be doing a swap. We're going to be replacing the 125 with D cube and replacing D cube with 125, which is mathematically legal. Okay, now go ahead and divide 640 by 125, and you'll find that your answer is in fact 5.12. Now we're doing the opposite. Okay, we're doing the complete opposite. To isolate D, or to remove the cube, the power cube from D, we're going to be doing the opposite of cubing, which is cube rooting. So therefore D is equal to the cube root of 5.12, which works out to be 1.72. All right, so that's what was required, guys. You will realize that if you are looking at your paper and looking at my solution, you'll recognize that you didn't do much incorrect. I was very impressed by quite a few of the students who actually leveled up compared to last month's results. You guys, some of you guys really leveled up, but some of you guys made the mistake right here where you calculated an incorrect value for k, therefore causing a domino effect in your calculation. All right, so hopefully you got some clarity on that, and then moving forward you will learn that you have to check to see if there's a relationship change between the variables. All right, so then we're going to be moving on to the ratio aspect of this paper. Now, I did find, and I really was very disappointed in quite a few students not applying the steps discussed in class. Now, I find that some of you guys may in fact require a ratio video, so I have one that is coming up during this week, perhaps probably about say Wednesday, Thursday, so look out for that. I'll be doing a complete tutorial on ratio as a reminder, not only for exams coming up but just for the purpose of learning. Now, where I find that a lot of my students struggle was with applying the 3 steps. Very surprisingly, I found that quite a few students started to apply all different types of methods to get into the answer, and consequently what has happened here is that they got the incorrect answer. Now, I did in fact discuss with my students, and of course you can confirm in the comment section, that there are in fact 3 very basic steps that must be applied regardless of the structure of the question, how challenging the question may come across. For this level of ratio, you have a 3-step process to which you must follow. Follow these 3 steps, you'll never struggle with ratio, and the consistency of your results is always going to be on a high. Okay, now give or take, depending on the question, you may have to use a bit of intuitive reasoning, or what I would say a little bit of common sense, but for the most part these 3 steps must be applied. Hence then, let's look at the question. A sum of money is to be shared among 3 sisters, Sarah, Sammy and Sandy, in the ratio 5 to 2 to 9. Sammy received $900 less than Sarah. You are to determine the sum of money that was shared. Now, can I safely say that more than 50% of my students, I'm gonna go out on a limb and I'm gonna say half my group got this question incorrect and the other half got it correct. Now let's look at my solution here. Now my solution here starts off with me writing down in fact the relationship or the comparative quantities. So I've written down here, the very first thing that I've written down here is in fact the fact that the money is being shared between Sarah, Sammy and Sandy. That's the very first thing that I do. And the next thing that I do is that I write down the ratio assigned to each individual. Now, once I'm successful in doing that, I've awarded my students half a mark just for doing that, because I really want to see you guys apply the steps. Then, the next thing that I need to do here is to find the total proportion. I need to find the total proportion. And so the total proportion is attained by simply me adding up the individual ratios. So you'll find here that total proportion is equal to 5 plus 2 plus 9, which is equal to 16 shares. This will later be of benefit to me if it is that the question asks for the total sum of money shared. Now, a little bit of intuitive reasoning is required here, because now the question earlier stated that Sammy received $900 less than Sarah. And what I find quite a few students, not a lot, but a few students made the mistake in terms of thinking that Sammy got 900 as opposed to Sammy getting $900 less than Sarah. The question then stands is, why has Sammy received $900 less than Sarah? Well, in the ratio it's quite obvious, because Sammy obviously has to have has to have less than Sarah because Sammy received less shares than Sarah. So the question is, what is the difference between Sarah's share and Sammy's share? So the difference between Sarah and Sammy's share is 5 take away 2, which is in fact equal to 3 shares. So the reason why Sammy is getting less than Sarah is because the 3 shares different is what is equal to the 900. Now, using that simple piece of information here, we can therefore calculate 1 share. 1 share is then equal to 900 divided by 3, which works out to be $300. Now, with this valuable piece of information here of $300, you'll find then that the question did in fact ask us to find the total sum of money that was shared. And that is in fact going to be the 16 shares, which is the total shares among the 3 sisters, multiplied by the value of 1 share, which is 300. Therefore, 16 times 300 is in fact 4,800. Lots of persons got this incorrect, but also lots of persons got it incorrect because they applied a complete different approach to the question. Most of you guys didn't go ahead and do it this way. Now, do you have to do it the way that I did it? No. If you know what you're doing, like quite a few students did, a lot of you guys got the correct answer by skipping out a lot of these steps. I gave you the full mark, because at the end of the day, there is no one way to do the math. But if you are a student who struggles fundamentally, as you know, my channel is based on giving students complete review on exam papers. If you struggle fundamentally, it's recommended that you take steps so you can easily attain consistent results. All right, so hopefully that gave you some clarity on that one. Okay, let's move on then to the next question. Now, we're looking in fact here at the concept or the topic of consumer arithmetic. And what I find in this topic is it's not the math that challenges most of you guys. It's really the English, the interpretation of the questions. A lot of students have expressed to me over the years and even in this year that challenging this particular topic sometimes it's not so much the fact that it's challenging to get the answer, but it's just the fact that students don't usually like worded problems. But for exam purposes, of course, I have to keep bringing these questions back. All right, so let's look at this consumer arithmetic. For this particular segment of the video, we're going to be looking at 3 or 4 different topics. We're going to be looking at sales, salaries and wages. We're going to be looking at, say here, sales tax, inclusive sales tax, how to approach questions like that. We're going to be looking at simple interest and how to move around the formulas. And we're going to be looking at, say here, hire purchase. So, nice 4 questions here that can knock off 4 aspects of consumer arithmetic that I find quite a few students struggle with. Let's have a look at question 5 here. Now, it did say here that Heather's weekly pay is directly proportional to the number of hours she works at a record store. Her pay is $174.50 for 18 hours of work. We are to find the number of hours she must work for a pay of $552.25. Now, there is a intuitive approach to this question, whilst there is also a formulated approach to this question. And you'll see here where I underlined, and I find that none of my students actually picked up that I was giving them a clue towards solving the problem. Here you're looking at the fact that the amount of money received by Heather is directly proportional to the number of hours she works. So therefore then, considering that these 2 words are very much related to topics that we have taught on the channel before, then I was expecting that a few students might have seen that we could have used the direct proportion approach to this question, where in fact here you'll see where I wrote down that Y, which is the amount of money received by Heather, is directly proportional to the amount of hours worked, which is represented by X. That's the approach that I took. a lot of students didn't really take that approach, which I'm going to be discussing with you in a moment. Now here you would have seen that the two initial values here, which is the amount of money she received versus the amount of hours she worked, which is 18. Hence then we place these in the equation, which is 174.50 or 174.5 divided by k, which we don't know obviously, and x, which is the amount of hours worked to attain that amount of money. By simply dividing both sides by 18, which is how to isolate k, you're going to find here that k, which is how much money she works per hour, or one share, that's $9.69. Okay, 174.5 divided by 18 is 9.69, so $9.69. Okay, so once we have established k, as advised in all my other videos, once it comes to this particular topic here, always rewrite your formula. So I've rewritten my formula here, y is equal to k times x. Once again, then the question is asking for how much hours, which is, as we said earlier, is represented by x. How much hours does she need to work in order to attain a weekly pay of $552.25. So by basic substitution here, y equals 552.25 equals k, which we just calculated to be 9.69 over here, and so dividing then by 9.69 gives us the value of x to be 57, or approximately 57 hours. It's about 56.9, rounded to about 57 hours approximately. So therefore then, that is the amount of hours required to work this. Now, lots of students didn't approach the question this way. I think they intuitively approached the question by simply dividing, say here, 552.25 by the current pay. They wanted to know how much times could the current pay go into the desired pay, and then by doing that they would have attained a result here of 3.616. but we know that there were 18 hours that was initially worked, so 18 multiplied by 3.16 gave you an approximate answer of 56.96, I believe, or 97, rounded to about 57 hours. So as I've always advised my student, pick your poison and move right along. Alright, so that was for that particular question. Then let's have a look at the next question, which is related to inclusive tax. Now, a customer paid $4,250.50 for a dishwasher, which was inclusive of 12.5% sales tax. Calculate the mark price of the dishwasher exclusive of sales tax. Now, before we actually go into the calculation of this question, there's a few things that you guys need to look out for in the future. In future quiz exams like that I give, and also CSEC exams, you have to look out for the fact that whether or not the money that is being displayed in the question is inclusive or exclusive of tax. Now, I find that quite a few of my students, what they in fact went ahead and do is that they went ahead to find 12.5% off 4,250. Now, when you do that, what you're basically doing is that you're calculating the percentage of an amount of money that already contains that 12.5%. So that's going to give you a very, very inaccurate answer. You have to recognize that if it is that the particular problem here contains, or it includes the tax, or it includes the interest, then this is what we call reverse direct proportion. This is where you're finding the mark price, or otherwise referred to as the original price. Mark price is also referred to as original price. Now, how do we go about setting up this question then? Let's have a look at my solution sheet. Now, the very first thing that I do when I'm starting my solution is that I establish the fact that if I'm looking for the mark price, which is the same thing as original price, it's very important you know that original price of anything, regardless of the price, is in fact equal to 100%. The original price of anything includes, that includes a sales tax or interest, which excludes sales tax or interest, is in fact 100%. Now, considering the fact that the $4,250.50 is already inclusive of the tax, then it simply means that the original price plus the tax that was included adds up to 112.5%. So therefore, the amount of money currently being displayed in the question is in fact equated to the 112.5%. This money already includes the 12.5. So that means I would have already had to include in this case means to add the 12.5 to the original. Now, if we set up this direct proportion problem here, that 112.5% is equal to 4,250.50, then easily by using ratio and proportion, we can find 1%. Or, simply put, we can find the value of K. So 1% is equal to 4,250.50 divided by 112.5. That is how we find 1%. Now, on the calculator, you would have attained the result here of 37.78. Now, bear in mind that we are in fact finding, say here, the original price, the mark price. So if 1% is equal to 37.78 and we're looking for 100%, then it's simply going to be 100 multiplied by 37.78, which works out to be $3,778. Now, for the purpose of examinations, you don't necessarily have to prove that your answer is correct, but for the purpose of the video, let's just show you how we can get back our answer, or very close to our answer. Understanding that 12.5% is an improper fraction, which then implies that 2 times 12 is 24 plus 1 is 25, and that's going to be 25 over 2, 25 over 2 over 100, because it's a percentage multiplied by the value, which is in fact 3778. Now, since the 2 is a denominator and the 100 is a denominator, we can make them into common denominators. This was in fact a lesson that was taught in one of my live classes. So then this gets reconverted to, say here, 25, as opposed to over 100, it becomes over 200 multiplied by 3778. Now, if we go on our calculator and we type all of this in, you'll find that we get 472.25. Now, if we add this 472.25 back to the original price here, you'll find that you get an answer of 4,250.25, which is very close. When rounded off, will be the exact value that we got before. Now, we're going to be a little bit off because of the rounding, because of the conversion from 12.5 to 12 to 12.5. So we're going to be a little bit off, but it won't be by much, because when we approximate the result, we're going to get approximately the same answer, which is not too far off and is within the margin of error. So this particular part of the problem we don't have to do when it comes to exam, but for the purpose of the video, I had to show you that if it is that we reverse the formula to get an answer, we should be able to forward the formula and get our original result. Right? So hopefully, guys, that was clear enough for you there. Let's move on then to the next question. So the next question then takes us into the aspect of simple interest. And so what we're looking at here is a man borrowed a loan of $35,000 with an unknown interest rate per annum for 27 months. Let's circle this, that's going to be key. And was charged interest of 3,300. Our task is to calculate the rate at which this particular interest was charged. So therefore then, what are we looking at? We have to revisit the topic of simple interest, and we would have learned that for simple interest, what we're then looking at here is the fact that simple interest is in fact equal to the principal multiplied by the time multiplied by the rate divided by 100. Now, as a reminder, the principal P is the amount of money that was borrowed in this example, or it could be the amount of money that was invested, which could be in another example. T represents the time, but specifically the time must be in years. So if you get a question that's presented to you in months, your task is to convert the months back to years, because interest is given on a annual basis. R represents the interest rate, which is in the form of a percentage of the interest given, or it's a percentage of the amount that was borrowed or invested. And of course 100 is the common denominator of percentages, or a constant. Now, there is in fact several ways in which we can make the problem easier. For some students, they kind of prefer an exact formula to find an exact variable that you're looking for. Well, for some students, transposition is a problem. They have challenges in algebra where rearranging the formula might be an issue. So of course, you're gonna find here that the formula for principal, or for finding time, or for finding rate, you'll commonly find that if your algebra skills is applied here, you're gonna find consistently that in fact SI times 100 always appear at the top. And so obviously then, if you're looking for P, then you'll notice that the other two variables are at the bottom, time and rate. If you're looking for time, then you recognize that principal and rate is at the bottom. And of course, if you're looking for rate, then you know that principal and time is at the bottom. So it's very simple to know this formula. Whatever you're looking for has the other two variables at the bottom, and simple interest will always appear at the top. Now, the question that we're looking at here, as read before, was in fact, we are looking for the rate. So using the rate formula, then you'll find that simple interest multiplied by 100 divided by the principal times the time, this bottom equation here, is what we will use to calculate the answer for this question. Now, when we read the question earlier, and we can just pull that screen back up in a moment here, it did say here, and we did highlight a few stuff. We highlighted the interest, we highlighted the time, and we knew that the amount that was borrowed, which is your principal, is 35,000. So now it's time to type in our values here. Our values here are in fact that the interest, simple interest, is 3,300 here, multiplied by 100, and then this is divided by the principal, which we said earlier was 35,000, multiplied by the time, which is going to be 27 months. Now remember that for simple interest, the time must be in years. So the easiest way to convert this to years is to simply divide by the amount of months that make a year. When you type this on the calculator, you'll find that the answer is 2.25. Or you could intuitively find out that 12 months equals 1 year, 24 months equals 2 years, and 3 months is equal to a quarter of a year, which is therefore equal to 0.25. But I think easily we should just divide 27 months by 12. That will give us the exact value of 27 months in years. So this is going to be 2.25. Some students rounded off to 2.3. Might be a little risky if your instructor requires the exact answer. So I do recommend that you write down exactly what you got on the calculator. Alright, then if we do say here 3,300, that's going to be 3,300 with 2 zeros, that's 330,000 divided by 35,000 multiplied by 2.25. So 35,000 multiplied by 2.25. Oops, pardon me, 35,000 multiplied by 2.25 gives us 78,750. Now if we go on our calculator here, 330,000 divided by 78,750 will give us an approximate interest rate here of rounded off to about 4.2%. So 4.2% is the interest to which this man had been charged interest on the amount of money that he borrowed. All right, so that was what was required to solve that question, and that would have gotten you a nice total marks here of 2. I thought maybe I was a little stingy with the marks, but I think that considering that you already have a formula, it didn't require too much work, so 2 marks I think was a reasonable amount for that particular question. Alright guys, we're coming almost to the end of the video. Do not forget to hit the subscribe button below and leave some questions and comments down below. If the video is of any value to you, please do not be afraid to share this out to all your other friends that may be in need of dire help when it comes to math. Whether you're a second former, third former, fourth former preparing for exam, or a fifth former currently in the process of doing your exams in 2024, please share this video out as well as the whole entire channel, because I'll be coming with exactly what you need to get the distinction in your 2024 exam. Alright, so here we go then. A bedroom set can be bought at a cash price of $36,500. However, there is a higher purchase deal available where a 20% deposit is required and 1.5 years of monthly installments of $3,550 each. Our task here is to calculate how much does the customer save by paying cash, and what is the interest percentage? What was the interest percentage charged? Now, when it comes to hire purchase, the interest is charged on a monthly basis, and so therefore in this example, as opposed to interest being given on an annual basis, the deposit here, hire purchase, is a monthly agreement. Interest is an annual agreement. So in this question here, you'll recognize that you have to convert the years to months. Okay, and we also have to understand that with hire purchase, this is where you are basically using a particular product or using a particular service by making partial payments on a monthly basis over a given period of time. So for this particular bedroom set, maybe the customer didn't actually have the full $36,500 to pay for the bedroom set. So they decided to take the deal and say, hey, pay 20% of the value of the bedroom set. So by starting the question here, we have to look at the fact that, say here, 20%. So 20% is of course 20 over 100 multiplied by the value of the bedroom set, which is 36,500. So if you jump on our useful calculator here, 20 divided by 100 multiplied by 36,500, you're going to find here that in order for this customer to acquire the bedroom set, they'd have to make a payment of $7,300 down. Now clearly there's going to be a balance to be paid, and that balance must be paid in monthly installments of $3,550 for the next 1.5 years. So therefore for the next 1.5 years, so 1.5 year in months is going to be 12 plus 6 months make a year, so that's 18 months. Pardon me, 6 months make half a year, so that's 18 months. 12 months make a year, 6 months make half a year, so 12 plus 6 is 18 months, is equivalent to 1.5 year. So therefore, for the next 18 months, this customer will have to pay $3,550 times 18. Alright, and this is me not using a formula, I'm just intuitively working out the problem. So 3,550 multiplied by 18, that gives us a total of $63,900. So therefore then, we know that over the past 1.5 year, $63,900 was paid, but remember that there was an initial installment made or deposit made of $7,003. So therefore, the customer would have made a total payment over the course of a year and a half of $63,900 plus the deposit $7,300. Therefore, the total paid here is in fact $71,200. Now, had the customer paid cash as opposed to taking the hire purchase deal, they would have obviously saved $71,200 minus the initial payment of $36,500. Therefore, $71,200 take away $36,500, the customer would have saved a total of $34,700 had they purchased cash. And that pretty much answers this part of the question. Alright, so as I said guys, if you're watching this video and you're wondering what makes this question so difficult, only my students would obviously be able to answer that question, because this question requires a little bit of thinking once you know what the meaning of hire purchase is. But now you know, if you messed that question up guys, you understand why you would have messed that question up. Okay, so let's move on to the next aspect or the next part of that question. We have already calculated that the customer is going to save $34,700, but we want to know what is the interest percentage. We want to convert that interest that was made as a percentage. Now, please bear in mind that when you are doing interest percentage, the interest is always compared, or the interest is the quotient of the total. So what then you're looking at here is in fact the interest that was earned was $34,700, and that would be compared to the initial amount that was charged. So that's $36,500. This is a lot of interest guys, times 100%. So the interest divided by the cost times 100, 34,700 divided by 36,500, that's equal to 95% interest. Okay, 95, and that's a lot of interest. Okay, considering the numbers in real life, if you were to have a hire purchase deal, then it's not going to be that much interest, but the numbers don't lie. If the numbers are what they are, then in fact in this case here it is 95% interest. So this particular hire purchase company was seeking to earn 95% profit on this deal. All right, so beautiful. That brings us to the end of that question, and it really brings us into the ending part of this paper here. So what we're looking at here is in fact the algebraic. Now in the last video we went through an example where quite a few students, my day school division, they made a complete mix-up with the rules for addition and subtraction and multiplication and division. And in this particular video here, I found that these particular students, they didn't make that mistake. They actually did pretty good and they had improved. So hats off to you guys. Now this last question here was actually a particular topic that I did like a day before the actual exam. So a lot of my students, in fact all of my students, probably 2 or 3 students got this incorrect out of probably about 70 students. So I know that this is something that we need to review. So coming up on the channel in a couple of days, we'll be going through questions of the distributive law in algebra. But let's wrap this video up right now and let's get into it here. So we're looking here at this question. And so remember that when we are adding and we are subtracting algebraic terms, the focus is going to be placed on the coefficients. We do not interfere with the bases. We leave the bases alone. But before we can actually do that, we have to group like terms. So let's group. We're looking for any other term in this expression here that has an a square b. And if we scour through the question, you'll realize that there's an a square b at the end. So that's minus 3a square b. And then obviously then if you look in the middle, these two are already grouped. So that's minus 3a cube b plus 2a cube b. So therefore then, our focus is only on the coefficient. 2 take away 3 is in fact negative 1. If you choose to write the negative 1, that's fine. But in algebra, we usually do not write the 1. We just normally just ignore the 1 because it's an understood coefficient. So the answer here is minus a square b. And minus 3 plus 2 is in fact again here minus 1. We don't write the 1. We just simply write minus a cube b. Minus a cube b. That is the result. Alright, now if you got this question incorrect, most likely you're still struggling with adding integers. So I'll leave a link in the description box below where you can access and you can take the time out to finally master the ability of adding integers mentally. We have to stop making the mistake of adding the 3 and the 2 and rewriting the negative. I found quite a few students only getting half the mark awarded for this question because they kept writing negative 5a cube b. That means that's a sign that you're struggling with integers. You need to fix that sooner rather than later. Then say here, let's move on to the next question. Our final answer there was minus a square b minus a cube b. Now this is the question then that I actually expected quite a few students to mess up, but they did in fact did fairly okay. Lots of students got really down to the answer, but we still have a few students messing up the signs. Now it is in this particular question here where our focus is not so much on the coefficient, but it's mainly on the powers here, 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 and here. Okay, so then let's focus first on arranging the numbers. We have 5 multiplied by, let me just get down here, need some space. 5 multiplied by 6 here, divided say here by 10. Okay, advanced students may never have to write this down, but my channel primarily focuses on students that are building up their fundamentals, so you take step by step to ensure consistent results. Now we're going to be grouping all the x's together. Say we have x to the 4th multiplied by say here x to the minus 2 divided by say here x to the minus 1. We're going to connect those with all the y's, so that's y to the minus 3, this y here multiplied by say here y to the 4. And most students may have made the mistake here where they recognize that this y didn't have a power, but we've said this time and again that if you see a variable without a coefficient, the understood coefficient is 1. Similarly, if you see a variable without a power, the power is understood to be 1. So then 5 multiplied by 6 is 30. 30 divided by 10 is in fact 3. Now since we're focusing on the powers, let's just rewrite the base, and then the power here is 4, but we are multiplying, which causes us to have to add this power of minus 2. So we're going to be adding say here minus 2. Now because we are in fact dividing, then division is going to cause us to have to subtract this power here of minus 1. So we're going to be subtracting minus 1. None of my students seem to have the patience to write this down. Remember, if you want to avoid the consequential result of getting the question incorrect or losing marks, then if you're not very good at adding integers in your mind mentally, then you need to write it down. I've said this time and again to you, my students. Write down your powers, then take care of the clashes if you're a fundamentally weak student. Say here then y, the power here is minus 3. Once again, because we are multiplying, we are going to be adding the power of 4. And over here then, we are in fact dividing. Say here, we're going to be subtracting, say here, 1. And so here, 3x, let's zoom up here, 4 plus minus 2, that is 2, 2 with a negative times a negative gives a positive. 4 plus minus 2 is 2, 2 plus 1 is 3. You can choose to type this on your calculator as is to get the consistent result, or you can do like what I just did, use the mental ability of adding integers. Please see the link in the description so you can get lessons on how to do that. Y, here I owe 3 and I have 4. If I could pay the 3 that I owe, I still have 1 left, and so therefore 1 take away 1 is in fact 0. Now I may have made a mistake. I think that was minus 1. Let me just go back to look at the problem. I think it was minus 1, was it? Okay, it was actually 1. So this is going to be minus 3 plus 4 is 1, 1 take away 1. So yes, it is in fact a 1. So therefore then what we're looking at then is in fact, okay, so negative 3 plus 4 is 1, 1 take away 1 is 0. So our final answer here is 3x to the 3, y to the 0 is 1, which basically multiplies by 3x cubed, giving us back 3x cubed. Some of you guys may have gotten full marks for this question, because I saw that some of you guys may have written down minus 1 as the power here. So if you got extra marks for this, consider yourself quite fortunate. I may have to do some adjustments to the grades, but nevertheless, this is going to be your result. Alright? And now to bring us to the end of the video, which is just about over, say here, approaching 2 hours. To wrap this up then, we're looking at this final question. And as I said before guys, prior to the exam, this would have been a fresh topic on your minds. So a lot of you guys, actually only one person got close or got the answer correct. Everyone else made a mistake. Now there's a couple of ways to approach this, but I'm going to be using it in the method that I've taught in my class. Now of course, with the distributive law, we already know, say here, that anything that is outside the bracket must be, well, in fact anything that is immediately outside of the bracket should be used to multiply what is on the inside. Now I did find that the students didn't make the obvious mistake that over the years I've found that students make where they distribute over a sign. Nobody actually made that error, so that's good. So what I find though is that students try to, say here, distribute the negative sign in here, and then it kind of got a little bit nasty, it kind of got a little bit ugly, and then they got a little bit confused. Now what I do advise, that when you get a question like this where you have distributive law and you have what is referred to as binomial expressions, it is recommended then that you take care of this aspect of the problem next. So first I'm going to go ahead and I'm going to distribute my 4 times x is in fact 4x, take away 4 multiplied by 3y, that's negative 12y. I'm going to return my minus 5 here, and then I'm going to make a distribution of my binomial expressions. Now, to do this then, what we're looking at then is in fact taking the 4 and distributing it with the y's and the minus 3 over here. Then I'm going to take the minus y and distribute it here and here. So notice that I have a bracket here because I'm going to be distributing my sign once I've completed the inside distribution here. So if I distribute here, see the 4, watch my purple arrow, the 4 multiplies the y, gives me 4y. The 4 once again distributes the negative 3 and gives me negative 12. Then I go to the bottom here, we call this the bird beat method, minus y multiplied by y, that's minus y squared. And of course, minus multiplied by minus is a plus, and y multiplied by 3 is 3y. Okay, and so that gives me the expansion of the inner bracket. So then we're going to be distributing the minus sign right across here. So we're going to be distributing that minus sign, and this is where most of the students got a little bit off. Okay, once they got to this point, they didn't have this bracket. So once this bracket is not there, it becomes an ambiguity question where it gives you a total different answer if you do not distribute that minus sign. So we're going to be distributing that minus sign here. So here and here and here and here. So the minus makes this 4y here negative 4y. Let's rewrite this first. 4x minus 12y minus 5. The minus turns this 4y into minus 4y. The minus change the minus 12 into positive 12. The minus change the minus y squared into positive y squared. And the minus changes the plus to a minus 3y. Now all the brackets are gone, and all we're left then here with is to group like terms, looking for all the terms that are alike. Now I'm going to rewrite my 4x here, and I'm going to check to see if there's any more x's that I could group with this 4x. There happens to be no more. Next I'm going to be looking at my y's. So minus 12y, it seems as if there's a minus 4y here, and there's also a minus 3y out at the end. So all my y's are together, and then we have the minus 5, then we have the positive 12, and then of course we have the final term here, which is y squared. Now nothing to group with the x, so the 4x comes back, but then we have 3 terms here that are exactly alike. And remember that when we're adding and subtracting algebraic terms, the focus is going to be on the coefficient. So we're looking at minus 12 minus 4, that's minus 16. Minus 16 minus 3 is in fact minus 19y. Now you'll recognize here that minus 5 plus 12 is in fact positive 7. Find that quite a few students got to this point, but they made the mistake by adding the 5 to the 12 and they got negative 17. Remember guys, you have to, if you're at this level, you have to have the ability to recognize integers. Minus 5 plus 12 is in fact positive 7, and then finally we have the y square here at the end. Alright, now you could write this in any order. The square could come first. Traditionally you're going to find that advanced teachers will write in descending powers, so they would have written the answer as y squared plus 4x minus 19y plus 7. That is also acceptable. So the order in which you write down your final answer won't matter, because at the end of the day, unlike terms cannot be added or subtracted. So hence, if you have any of these results or a variance of these results, then you know that you are in good standings. Alright, so that pretty much brings us to the end of this review paper. It did cover quite a lot. I did have some fun, and I must say that congratulations to quite a few students who scored into the 90s and into the 70s. They really, went hard on this paper, and like I said, these are fundamental skills that you're going to find that you yourself may be struggling with. All right, so I do hope that you actually enjoy this particular tutorial and you found value in this review. Ensure that you actually have this video to watch time and time again. Use this video in preparation for the next exams, which is coming up. You have 2 more exams, guys, and hopefully you'll be able to score higher and higher, because all the other exams will have variations of these types of questions. All right, so until then, I'll see you next time in another tutorial. Do not forget to hit the subscribe button below, turn on your post notification bell, leave some positive questions and comments, and share the channel link out to all your other friends. Help each and every student to become stronger and better, and to prepare for that 2023-2024 exam. So until then, see you next time. Bye bye.